This is Unit 2, Section 2, Polynomial Functions, Day 2. So first we're going to talk about how to find the y-intercept of a function. So if you notice here, we have 0, 1 is our y-intercept, and if I look at my equation, if all the x's were gone, I'm left with 1. And here I have 0, -2, and again, if I got rid of the x, I got -2. So when we are looking for the y-intercept, we're really looking for what's the value when x is 0. So let's do that. Let's find the y-intercept by plugging in 0 for all of the x's. So we're going to get 2, no, come on. 2 minus 7 times 0 to the third minus 7 times 0 squared minus 0. So it goes away, goes away, goes away, and I'm left with 2. So 0, 2 is that y-intercept. If I do the same thing here, I just have to focus on what's happening inside of the parentheses. So we're going to get -2 times 3 times -2 squared. Make sure you square that first. So now we have 2 times 3 times 4 times negative, so that's -24. So 0, -24 is the y-intercept. So go ahead and try these two. You can pause it and I'll show the answer. All right, so for number 1, we have 0, -5, and for number 2, we have 0, 0. So something we want to look at when we're graphing are repeated zeros. So that's when a solution of a polynomial shows up multiple times. So the multiplicity of a zero root is the number of times that that shows up. So if I had x minus 1 squared, that means x minus 1 and x minus 1 are both factors. So x equaled +1 was a root twice. So it had a multiplicity of 2. X plus 4 is being raised to the third power, so the solution, or 0 of x equals -4, has a multiplicity of 3. If the multiplicity of a 0 is odd, it's going to cross at that x-intercept. But if it's even, it's going to bounce. So if you had a line, it would go towards it, it would hit the 0 and turn the other way. And that's what's going to happen when it bounces or when it's an even multiplicity. So we're going to use everything we know now about polynomials to graph. It's just going to be a rough sketch. It's not going to be exact, but we are going to make sure we focus on the intercepts, both x and y, the end behavior, and the multiplicities of the roots. So the first thing I usually look at are my zeros, right? So I know I'm going to have x-intercepts or zeros at -3 and at +2, right? We get that by taking the opposite sign of each of those. So I can already graph at -3 and +2 my zeros. I also look here. There was no exponent for this, so it's going to go through that 0. Right? That'll come into play later. This one had a power of 2. That's an even multiplicity, so it's going to bounce at that 0. I can also find the y-intercept, right? If I plug in x is 0, so we end up with 1/6 times 3 times -2 squared is 4. Right, so now 4 times 3 times 1/6 is 2, so we have a y-intercept of 0, 2, so I can graph that point as well. And I'm going to look at my end behavior. I have 1, 2, 3 parts, or 3 x's, so it's an odd function. The number in front is positive, so my end behavior is going to look like that. So I already know this side's going to go down here, this side's going to go up here, and all I have to do now is look at through this one and bounce at this one. So it's not going to go past that. It's just going to turn there, but it went through at -3. All right, next example, same idea. My zeros are -2, +1, and +3. So -2, +1, and +3. And all of them had a multiplicity of 1, which means they go through all. All right, I'm going to find my y-intercept. So we have 0 + 2, 0 - 1, and 0 - 3. So 2 times -1 times -3 is a +6. So we have a y-intercept of 0, 6. And I have 3 x's, so the degree is odd. The number in front is technically a +1, so that's positive. So that's my end behavior. So we know down on this way, up on this way, and it's going through each of these. So we go up to there, down to there, something's going to happen, we turn, and that's our graph. So you go ahead and try this one, pause it, and then I'm going to show the answer. All right, so our graph should look something like that. The last problems we're going to do, we're not going to focus a lot on these, but we are going to give them a try. So here, they're telling us a few things. F is increasing when x is less than 0 and bigger than 4, and it's decreasing between 0 and 4. It's positive between -2 and 3. So that's really where I'm going to start my problem. Between -2 and +3, the graph is somewhere up here. And between greater than 5, it's also going to be positive. And we're also looking at negative, right, under the x-axis when x is less than -2, so over here. So we know it's going to be down like this. And then also between 3 and 5. So in this area, we're going to be down. So now what I'm really looking at is the increasing and decreasing to know where it turns, right? Where between these 2 points it turns and where between these 2 points it turns. So it's increasing when x is greater than 0, less than 0. So it's increasing until we hit 0. So somewhere on this y-axis, when x is 0, it's going to change. And then it starts decreasing, and it decreases from 0 to 4. So somewhere where it's 4 is where it's going to change again. And then at that 4, it'll go back up, and it increases for everything bigger than 4. So that is a rough sketch of what this could be, right? It could be much higher here. It could be much closer here. This is just a rough sketch. And then use the graph to describe the degree and leading coefficient. So because it has opposite directions, we know it's odd. And the end behavior shows down to the left, up to the right, so that's positive. So you're going to try the last one. All right. It's okay if you can't get this, but give it a try, pause it, and I'll show an answer. All right, so what we should have had was a turning point at x equals -2 and a turning point at x equals 3, and it passed through at -5, 0, and 5, sorry, -4, 0, and 5, and then end behavior was up on the left and down on the right, and that's the end of that lesson.